We're going to work a problem. And in this problem, we're going to work on two skills. The first one is to practice identifying the major information given in our word problem. And the other one is to use Desmos as a tool to help us do some intermediate calculations. Here's the question. Traditionally, the amount of time it takes to complete a statistics exam has a skewed left distribution with a mean of 60 minutes and a standard deviation of 10 minutes. If 64 students are randomly sampled, determine the probability that the sample mean of the sampled students is less than 56 minutes. Okay, let's start to break down what's going on. Um, as we read, the first sentence is going to provide us with a mean and a standard deviation. So if I were to write those down, we have a population mean, because this is just in general. They know it takes about 60 minutes on average to finish the test. Everybody's a little different. They don't finish exactly at the same amount of time, but the standard deviation is calculated out to be 10 minutes. So that is the mean of the population, 60, and the standard deviation of the population, 10. The second sentence gives us the fact that there are 64 students, and so that gives us the number in our sample. And also, it mentions that they want to know that the probability of the sample mean is less than 56 minutes. So the sample mean, X bar, is less than 56. And ultimately, the problem is a probability question. So that's the big task there. Sort of learning how to dissect all the word problems that are given in this course. So that was our first skill, is just reading over it, recognizing the first sentence is a more global statement about the test and how long how long it takes students to complete it. And then the second sentence, we have more of a specific to a sample of 64. In order to find this probability, there is a step we need to accomplish, which is to compute the standard deviation of this sampling distribution of means. Now, we know that it doesn't matter what the population data's distribution is. In this case, it's skewed left. It really won't matter because the person who put this together was smart and used more than 30 students here in their sample. So that's going to ensure that our distribution of the sampling means will follow a normal distribution. And this is the adjusted standard deviation. So if you notice, we were given this information already in the problem. The population standard deviation is 10. That will occupy the numerator. And the sample size is under the square root, 64. So we want to determine what 10 divided by the square root of 64 is. So you can either do this with a handheld calculator. I found that Desmos is an excellent tool to use for some of these more complicated looking calculations. And so this right here is what we're going to enter into Desmos and have it do that work for us. Here's Desmos. It's the scientific calculator of Desmos. And so I can write it, I like to say, and type it, then I can trust that Desmos is going to do the right thing for me. So ultimately, our calculation is a fraction. So I'm going to grab, if you look under the wrench here on the right-hand side, you can kind of see it blinking now. There is an A over B, which will give me the numerator-denominator split. Our numerator was 10. Our denominator, you can either use your down arrow key or just tap underneath, is the square root of 64. And you can see there that 10 divided by the square root of 64, look all the way to the right side, is equal to 1.25. So if I go back into OneNote, we now see that this value is 1.25, and that would be the standard deviation I would use in our guru to finish up this calculation. Again, this video is primarily on how to use Desmos to do some of these intermediate calculations you need to do before you can use our statistical software for our course, which is our guru. Thanks for listening.